All right, so that's Antarctic sea ice. So let's switch our attention to mountain glaciers and things that happen in mountain glaciers. So in this exercise, we're going to complete this cross section, this profile from Yosemite to El Capitan. So how do you do that? How do you make a cross section? So I'm going to take you through the steps in doing that. So here's El Capitan, the falls here, Brattleville Falls, and this is the little map on back on 350 that we use. So 350 is what we're going to use to make this cross section. 350. Let's 13.12. That's 350. Oh, that's not right. Use the profile on page 13.2.1. So where's 13.2.1? I guess that's in the next. No, 13.2.1. 13.2.1. We're going to 13.12. So 13.12. Where's that? It's over here on page. Yeah, 359. Okay, so you got to go to 359, and we're going to, between these two pages, we're going to get the information we need to fill out the chart. So 359 looks like that. And so we're going to use this profile box to connect the dots, right? So the way you do that is you have to take that profile box out of your lab manual and put it up against the map. Well, to make it easier for you guys, I just made this for you, all right? So what you can do is you can use the slide 44 to make the cross section. So if you do that and put the dots in of the different main elevations from these contour lines and project them down, you'll get a distribution of points like this. And then since you have those points, then you can connect the dots, all right? So this technique of making a topographic cross-section is a way for us to go from an image of a map view to a cross-sectional view from looking at it from the side. So if you have difficulty doing this, you can just, I guess, copy page 45 and connect dots. But the point of the exercise is just the purpose of it is to illustrate to you the technique that we use to draw cross sections from topographic maps. So here's the second cross section. It's a little more difficult because if you look on there on page 59, it's at an angle. So what I did is I just took the image and I rotated it for you so that it's a little more straightforward. And then I brought in the lower part of the chart there on page 369 to make it a little bit easier for you to plot the points. And so now all you need to do is plot the points. So here's 5,800 feet. So that little dot would go right there. This is 5,600 feet here. So at any rate, you see, you could do this by cutting take it out, copy it, take it out of your manual, fold it, put it up against the cross-section line. I'm not insisting that you do that. I'm just saying that's the way that the lab was set up. But I don't think you necessarily are learning anything by cutting and pasting cross-sections. So that's why I did this for you. The outcome of this approach would be to get a distribution of points like this, and they're amazingly symmetrical. Well, that's intended to impress that upon you. And then you got the dots, you can connect the dots. A lot of science trying to connect the dots, like right now, this COVID-19 situation, it's a bunch of very smart people attempting to connect dots, the data, and they never have enough data. That's why they wanted the testing. More data, you come to a sounder conclusion. Well, but I think what lesson for you guys is this whole experience that we've all gone through is this is an experience that you can carry with you into your lives as far as understanding how science works, and that is that you initially have a little bit of data, you make some assumptions based on that data, and you make some projections. Well, in the early days, they didn't understand the severity of the thing, so they made some assumptions about, well, it wasn't that big a deal, and then it was a big deal, and then how big of a deal? Well, you're going to kill 1 million people and put the brakes on everything and stop, and was that necessary? If you put the brakes on quick enough, take it off now, you could go to first gear. It's all based on assumptions and lack of data. So some people never make a decision, they just collect more data, but eventually you got to make a decision. So, and maybe we'll be back in the fall, maybe we won't. I know we won't be back in the summer. At any rate, projections. Okay, so here was, there's the solution to step 3 on 369. And then over on 370, there is yet another topographic exercise across the Merced River. And so it's the same procedure. You can cut and paste it, but I'm going to save you the trouble by giving you the solution. Just so you understand the technique, you put the cross-section up against the map, and then you project the elevation lines into the cross-section. So to do this, it's helpful to first put elevations on the map, make it a little easier for you to know where to put the points. So then you have our points there, you can connect the dots, and you have a profile. So you can see this one is not as symmetrical as the other one was. It's got a little bench here going up. So something different than in the Bridal Veil Fall cross-section. And so your question number 4, there in 370, asks about the lower part of the Merced River Valley and erosion that might have happened there, and what this erosive activity as opposed to the glacial activity may have, the consequences were for the cross-section or the profile of the valley. And the answer is that there is this change in the profile at 3,800 feet. So I'll look here. So here's 3,800 feet right here. See that change in the profile? That's what we're talking about. Instead of this being symmetrical, something happened. Well, the something that happened was the fluvial activity of the Merced River. So the answer is that the rocks above 3,800 feet were largely carved by the glaciers. The rocks were modified below that level and mainly excavated by stream action. So the interest there is to impress upon your minds the give and take between glacial and fluvial processes. So that brings us on over to questions QB 1 and 2 on the bottom of 370. Based on your work, complete the following sentence, and then interpret whether Bridal Veil Falls is likely to have been shaped by a river or modified by a glacier. Explain your reasoning. So there's a U-shaped and a V-shaped valley. And let's go back up and look at the profile. Remember the profile? That was this one. Well, that looks like a V to me. All right, V-shaped, and not a lot of deviation from Venus. So based on that, you would say what? Well, you'd have to say valleys eroded by rivers tend to have V-shapes, and valleys tended by glaciers have U-shapes. That's straight enough, weird enough. And Bridal Veil Fall, well, it's high up in the canyon wall, and it was originally a side glacier, but the stream converted it from U to V. So it originally was a high altitude glacier going into the mother glacier, but since then it's been eroded to form the V. It was U, and now V. And there she is. So like we've been here for 36